All right, today we're going to be looking at section 7.5, exponential and log equations. At this point, we know, or at least we've seen, all the properties of log, which I will revisit them here, and then I will also give you the formula for compound interest, as we will be using that in this section, and then from there we will solve these problems. So I'm going to give you the properties of log first. So properties of log. Given log base b of, we'll just say, x times y. So when you're evaluating multiplication within a log, you can rewrite it as log base b of x plus log base b of y. So multiplication property. We also have division property. Log base b, and we'll just say x divided by y. So if you're evaluating log and division inside, you can rewrite that as log base b, and this time it'll be x minus log base b of y. Important thing to note is that if they have the same base, so you can go forward this way, or you can see it as addition and go backwards and write it as multiplication. Same thing here. And then you also have the power property. Log base b, and we'll say x to the a power. Okay, this exponent can come down to the front as a multiple, and that would be a times log base b of x. So these are the three prominent properties that we will be using when applying these log and exponential equations. And then there's one more formula, compound interest formula, that we will see toward the end. Compound interest, that formula is A equals P, open parentheses, 1 plus R divided by N raised to the N times T power. And then I'm going to give you a shorthand formula. So this is annually, if it's compounded annually. The formula shortens up to be A equals P, and then 1 plus R raised to the T power. So annually means N equals 1. So when N is 1, when you divide by 1, you just get what you originally started with, and when you multiply by 1, you get the same thing you had. So I'm going to give you what each of these letters mean, and then we'll just start working a few problems. So A is the final amount. P is the principal. Or starting amount. Now, this starting amount could also be the borrowed amount, so, but anyway, the principal is the financial term that they want to use for what you start with, or what you borrow, what you invest, etc. R is the interest rate. I'm going to say as a decimal, because you got to convert that to a decimal. So you'll be given an interest rate as a percentage. You convert that percent to a decimal. T is time in years. T is time in years. Sorry, it's cut off. And then N, number of times interest is compounded. Now, to figure out N, you just have to be familiar with the terms that they use. So annually is one of the terms. That means N equals 1, but there are several other terms you might see. So you might see semi-annually, semi-annually, N equals 2. You might see monthly. That gives you N equals 12. You could see quarterly. Quarterly, N equals 4. And then so on. You can get weekly, which is 52. You can get daily. I'll go ahead and write those two. Weekly. N equals 52. It's 52 weeks in a year. And then daily. If they do daily, they just let N equals 365. Okay, so they just ignore the leap year scenario because every 4 years is 366, but 365 is what we use. So these are the different terms that will help you to identify N. And then once we identify each of these parts, we just plug them into the formula and then we solve it. So just a reminder, these are the properties we're going to be heavily using, more so this log property right here. And then from there we should be able to solve all of these. All right, so we're going to go ahead and stop here, and then we'll pick back up and answer problem number 1.